All right, these are the notes for 7.4, parallel lines and proportional parts. So there are a couple more problems, so if you'd like to look at that and check out my work, that's great, but I want to jump right into the new stuff. So, triangle proportionality theorem. If a line within a triangle is parallel to one side of the triangle, so a line in a triangle, it's parallel to one side of the triangle, then the sections created by the line are proportional. So in this image, AB to AE equals BC to ED. So those get split proportionally. Then the converse of that, if you have a line within a triangle, so like this, and you know that those sections are proportional, then you can say that line is parallel to that side of the triangle. All right, so let's use the theorem and its converse. So for this first one, in triangle PQR, ST is parallel to RQ. If PT is 7.5 and TQ is 3 and SR is 2.5, find PS. Well, since ST is parallel to RQ, then we know that the sections created are proportional. So we could do x to 7.5 equals 2.5 to 3. All right, so then we cross multiply. We get 3x equals, and then 7.5 times 2.5, 18.75, and then divide by 3. X would equal 6.25. So PS is 6.25. Then using the converse, now we're doing the opposite. In triangle DEF, EH is 3, HF is 9, DG is 1/3 of the length of GF. So we don't know either of those lengths, so that we could say GF is X and DG is 1/3 of that, so 1/3 X. Is DE parallel to GH? So for those to be parallel, the side segments have to be proportional. So it means X over 9 needs to equal 1/3 X to 3. So if I cross multiply, X times 3 is 3X. And then if I do 9 times 1/3, I get 3. So 3X. Those equal. So yes, DE is parallel to GH. All right, moving on. Triangle midsegment theorem. Midsegments, which is the segment created by the midpoints of two sides. So JK is the midsegment. It's created by the midpoint of FH and GH being connected. Midsegments are parallel to the side it does not intersect. So JK is parallel to FG and is half of that side length. So JK is half of FG. So if FG was 10, JK is half of 10, which is 5. All right, so in the figure, XY and XZ are midsegments of triangle RST. Find each measure. So XZ. XZ is the midsegment of the triangle. So one of the midsegments, I should say. So it's parallel to this side, and it's also half of this side. Well, RT is 13, so XZ is half of 13, which is 7.5. All right, ST is this side here. And we have midsegment XY, which doesn't cross ST. So it's XY and ST are parallel, and XY is half of ST. Well, that means ST is double of XY. XY is 7, so ST is 14. Be double of 7. And then we have the measure of angle RYX, which is this angle here. We only have one angle that we know, which is the 124 degrees. These two angles share this line. But then notice that that line is a transversal for RT and XY, or XZ. XZ is a mid-segment, so that means XZ is parallel to the side it doesn't cross, RT. So 124 and this unknown angle are alternate interior angles, so they are congruent. So that would also be a 124-degree angle. Moving to the back, proportional parts of parallel lines. If 3 plus lines are parallel, then the parts of all transversals are proportional. All right, so what does that mean? Okay, that means in this image that AB to its other part, BC, equals EF to FG. And this also equals AC to EG. So the entire lengths of those transversals. So AB is to BC equals EF to FG, which equals AC to EG. And then congruent parts of parallel lines. So you have the same situation, but one of the transversals, the parts are all congruent. So AB is congruent to BC. That means it's true for all transversals. So EF is cut into congruent parts to make FG. All right. In the diagram, angle ADE, angle BEF, and angle CFG are congruent. What does that mean? Well, if you look at this line that they all share, they're all on DG. And that line cuts all 3 of these lines. And if all of these angles are congruent, and those are all corresponding angles, congruent corresponding angles tells you that lines are parallel. So that is telling us that these 3 lines are parallel. So then we can use what we just learned above. If AB is 30, BC is 12, and DE is 35, find DF. Well, I'm thinking we're going to want to find EF, because then we can make the proportion 30 to 12 equals 35 to x. So 30x would equal, and then 12 times 35 is 420. So x equals 14. So EF is 14. So then DF would be 35 plus 14, which is 49. Next one. We are going to find, well, it doesn't tell us what to find. Okay, let's see. We've got this length and this length. We have this length, but we don't have GH. Let's find GH. Okay, so x to 120 equals 300 to 150. So if we cross multiply, 150x equals 120 times 300, 36,000. And then divide by 150, x equals 240. So GH equals 240, and then we have a unit, so yards. All right, I want you to pause here and try this one on your own. Find the shoreline of lot A. All right, so the proportion you should have gotten should look like that. Cross multiply, solve, you get 82.86 yards. All right. Now we're looking at a triangle. Okay, but we do have parallel lines. This line would be parallel to this one because corresponding angles are congruent. And then this transversal cuts it into congruent parts, meaning all transversals do. So that means this transversal here is also cut into congruent parts. So 2x plus 1 equals 3x minus 5. So then 1 equals x minus 5, so 6 equals x. All right, just a couple more. So we're going to solve for x. We have 3 parallel lines cut by 2 transversals, and one transversal is cut into congruent parts, meaning the other one is as well. So that means 6x minus 5 equals 4x plus 3. So 2x minus 5 equals 3. 2x equals 8. X equals 4. And that was using the congruent parts of parallel lines. All right, I want you to pause here and now solve for y. All right, so we know that 3y plus 8 equals 5y minus 7, and then you just need to solve for y. Y equals 7.5. All right, and that completes the notes